Hello everyone and welcome to another video in this series about the basics of C# programming with Unity. Today we are going to talk about conditions. They enable decisions to be made in the code and certain instructions to be executed only if certain conditions are met. Whether in games or in any other program, conditions are everywhere. So let's get started. First of all, what is a condition? A condition in C# allows you to choose which code to execute depending on the value of an expression. This means you can have different behavior depending on the value of the expression. There are three types of conditions in C#: if else, and switch. Let's start with the first type of condition, the if. We start by writing the if keyword followed by a pair of parentheses, between which we write a Boolean expression, meaning that this expression must be able to be evaluated as either true or false. Finally, we add a pair of curly braces between which we write the instructions to be executed. These instructions will only be executed if the expression evaluates to true. So, if the expression evaluates to false, these instructions will not be executed. For example, we can test whether the player's life is less than or equal to 0. In this case, we call a method called GameOver. Otherwise, if the player still has life, we do nothing. The second type of condition is the if-else. It starts in the same way as the if seen previously, but then we add the keyword else, followed by a pair of curly braces that also contains instructions. These instructions will be executed if the expression evaluates to false. So, if the expression evaluates to true, we execute the if instructions, and if not, we execute the else instructions. Here is an example of a condition that can be tested in a shooting game when the player wants to shoot. If there is any ammunition left, the shot is fired by calling the shoot method. Otherwise, the reload method is called to reload the weapon. If else can be chained together to test multiple conditions. For example, we could award a medal depending on the player's score. If the first expression evaluates to false, we evaluate the next expression. And if it evaluates to false again, we continue. As soon as we come across a condition that evaluates to true, we execute the corresponding instructions and stop evaluating the following conditions. So here, if the score is greater than or equal to 500, a gold medal is awarded. Otherwise, if the score is greater than or equal to 400, a silver medal is awarded. Otherwise, if the score is greater than or equal to 250, a bronze medal is awarded. If not, a message is displayed to encourage the player to continue. In this case, pay attention to the order of the conditions. If we reverse the order of the conditions, in this case we'll always get a bronze medal as long as the score is greater than or equal to 250, as this is the first condition to be tested. So, even if the player obtains a score of 600, this first condition will be evaluated as true, and in this case the following conditions will not be evaluated. Let's test it out in Unity. Create a script and call it conditions. Open it in Visual Studio. For the example, we'll imagine that our player can interact with a treasure chest, but he can only open the chest if he has the key. We declare a boolean hasChestKey and give it the value true. Then write an if condition which takes hasChestKey as its expression. And between the curly braces, we'll add a debug.log to indicate that the chest has been opened. Let's go back to Unity to test. If you still have the game object from the previous episode, you can delete or deactivate it. Create a new game object and add our script to it using drag and drop. Then click play. We can see in the console that the chest is now open. And if we set the hasChestKey boolean to false and test again, nothing is displayed in the console. We can modify our if and add an else to execute instruction in the event that we don't have the key. In this case, we'll do a debug.log to indicate that the key is missing. If we test again in Unity, we now get a message in the console when we don't have the key. Sometimes we need to test several conditions. In this case, we can use several if-else tests in a row. Take, for example, the case where we need to assign a rank to a player based on his score. The maximum score is 100. First, we'll store the player score in a score variable of type int. We'll start with 95 for the value. Next, we can write an if with the expression score greater than or equal to 90. In this case, the console will display that the player has obtained rank A. We then follow this up with an else if with the expression score greater than or equal to 75. in which case the console will display that the player has obtained rank B. Here, the condition score greater than or equal to 75 will only be evaluated if the first expression is false. You can then continue with other else if, for example, if the score is greater than or equal to 50, the player obtains rank C. If the score is greater than or equal to 25, the player obtains rank D. And finally, an else to indicate that the player obtains rank E. Here, the else will only be executed if all the preceding if conditions are false. We can test in Unity. A score of 95 results in rank A. With a score of 80, we get rank B. And with a score of 20, we get rank E. We will now look at the use of the last type of condition, the switch. The switch is used to execute instructions depending on the value of an expression. With if and if-else, we were using Boolean expressions. But this time we can use the value of the expression directly. Let's imagine that you have the type of enemy the player is fighting in a string variable. The value of this variable could be boss, elite, or standard. And we want to play different music depending on the type of the enemy. You can use an if-else-if structure to achieve this, as shown here for example. If the enemy type is boss, we play the music for the battle against the boss. Otherwise, if the enemy type is elite, we play the music for fighting an elite. Otherwise, if the enemy type is standard, we play the standard battle music. Otherwise, we just play ambient music. But we can also use a switch type structure. To do this, we'll start by writing the switch keyword, followed by a pair of parentheses in which we write an expression, in this case enemy type. Then a pair of curly braces. Between these curly braces, we can define the different possible cases, so the different values of our expression, followed by a colon. In our example, we have the following cases: boss, elite, and standard. For each case, we write the instructions to be executed, so here we are calling the methods that play the right music. Finally, we end each case with the break keyword. Cases are evaluated in the order in which they are written, from top to bottom. You can also add a default case in the event that no other case matches. So we add default, a colon, then the instructions to be executed, such as playing ambient music for example, and finally the break keyword. The default case will always be evaluated last, so only if no other case matches, regardless of its position inside the switch. Generally, the default case is placed at the end. Let's test this out in Unity. Let's imagine that the player can pick up objects in the game and get a certain number of points depending on the type of object picked up. We'll start by declaring a string variable called objectType and giving it the value sort. Now we create a switch to assign points according to the type of object. So we write the keyword switch, then between parentheses the variable objectType. Finally, we add a pair of curly braces. Let's start with the first case, if objectType contains the string sort. Then a debug.log to display in the console that we've earned 10 points. And then the case with the break keyword. We then add the case where the type of the object is potion and display in the console that we've earned 7 points. Then the food case, which earns 5 points, and the drink case, which also earns 5 points. We can add a default case. In this case, a message is displayed to indicate that the type of object is unknown and that no points are awarded. Let's test it in Unity. It shows us that we've gained 10 points for the sort. Now let's test with the potion. It gives us 7 points. In a switch, we can group the cases together if, for example, we have to execute the same instructions for several cases. Here we gain 5 points in the food and drink case. So we can group them in this way. In this way, these instructions will be executed if the type of the object is either food or drink. We can also use the OR keyword to get the same result. We could also take the previous example with the player's rank depending on the score, and adapt it to the form of a switch. And why not make a new method out of it? So we'll create a new method that returns a string. We'll call it getPlayerRank, and it takes the player score as a parameter. A switch is made on the player score, and the different cases are taken into account. Here, in our cases, we don't take a precise value into account, but compare it to a constant value. If the score is greater than or equal to 90, the A rank is returned. Here we don't need to use the break keyword. The return keyword is used instead. We can complete our switch with the other ranks. And by default we return rank E. Be careful here about the order of the cases. They are evaluated from top to bottom, so if we test first if the score is greater than or equal to 25, we get an error telling us that some cases are not accessible. In fact, after the first case, all scores greater than or equal to 25 will already be taken into account, so the following cases cannot be reached in this case. We can now test our method by calling it in the start method. Let's do a test with a score of 95, 52, 25, and 8. Let's test it in Unity. And we obtain the desired ranks. It is also possible to use the AND keyword to make several comparisons. For example, for rank B, we can specify a score greater than or equal to 75 and strictly less than 90. The same can be done for rank C and D. In this case, we can reorganize our cases because they are more precisely defined and do not overlap. When we use a switch to return a value, as in our example here, we can use another way of writing the switch. First, we write the return keyword, then the variable to be evaluated, and the switch keyword. Then, between curly braces, the conditions corresponding to the cases, a fat arrow with equal to and greater than, and finally the value to be returned. The cases are separated by commas. And the default case can be defined by an underscore. The return statement is terminated by a semicolon. There is also a ternary conditional operator. This operator consists of a question mark and a colon. It is used to return a value based on a Boolean expression, so either true or false. It is used as follows. Here, condition represents the Boolean expression to be evaluated. If true is the value to return if the expression evaluates to true, and if false is the value to return if the expression evaluates to false. Let's take an example. We want to place the text "you win" in a message variable if the player score is greater than or equal to 50, and the text "you lose" if the player score is less than or equal to 50. We can do this with an if-else, like this for example. We declare a string message and then an if, score greater than or equal to 50, we put "you win" in message, and if not, we put "you lose" in message. But you can do the same thing with the ternary conditional operator. We have the condition, the value to be placed in message if the condition is true, and the value to be placed in message if the condition is false. These two ways of writing give the same result. Using the ternary conditional operator makes for more concise code. But be careful that it doesn't affect the readability of the code. If it becomes difficult to understand what your instruction is doing, use the classic if-else structure instead, even if it takes longer to write. And that's it for this video in conditions in C#. I hope you found it useful. If you have any questions, don't hesitate to ask them in the comments. Thanks for watching and see you next time.